Well, hi, and thanks so much for joining me here in my shop. Today, another gray, rainy day here. Oh boy, and cold. Just a little above freezing today. Son of a gun. Another good day to be in the shop. And what's happening today? I want to try to find out why this radio didn't receive any short wave. In the last video, after doing some of the alignment, I discovered that this thing's sensitivity on short wave, well, certainly on the 19 meter band, seemed to be extremely low. So the first thing I'm going to be suspicious of, first thing I am suspicious of, is that the first tube here may be weak. This is the only tube that's subjected to high frequencies, such as trying to tune in 10 megahertz or something like that. The 10 megahertz signal is supplied to this tube, but to nothing else. This is the only one that might be sensitive. So I'm trying to answer the question, why does it seem to work fairly well in AM, but not hardly at all in short wave? And so I think it's just maybe the higher frequencies of short wave receptions, much higher frequencies, and maybe one of the tubes, it would have to be this one, can pass the lower stuff, so the AM works, the broadcast band works, but the short wave doesn't. So we're going to test this tube. Now, figuring this out in a tube tester, well, tube testers aren't using high frequency, certainly not the ones I have anyway. So exactly why a tube that was weak on high frequency would show up on my tube tester, I'm not sure. But let's check this guy out and see how it stands up. 6SA7. Now I have quite a number of these tubes, and I've tested them all in this tube tester, and I have a record of them all. So I can fetch any 6SA7 tube I've tested previously. Let's see here, 6.3 JR, in you go. Just check the settings. This tube tester tests a 6SA7 twice. There's an amplifier and an oscillator in here, if you like. And it tests them separately in this tester, which I think is a good idea. My other tester, my other good Weston tester, would test this tube with one test only. So you can't really tell the relative strengths of the two parts. Not with my other tester. My other tester. So we should be ready to go here. First thing we're testing is the amplifier. So conceivably, this is what's weak in the radio. So it should come up at a minimum to about 500 here on the dial. Good. You can see that quite nicely. Today, here we go. Okay, so it's coming up at 600 as opposed to 470. A good tube, like a good one, would show up at 750. So not a lot higher, but it would be higher. Well, let's take a look at the oscillator side of this tube. 5346. 5346. 7. 2134. The same. Just in case. Shorts. Again, should be the same. Above 500. So the oscillator side tests higher. So, you know, that suggests the tube is okay. Maybe okay is not really good enough in this case. Let's go back to what we're getting here. 600. So what I'll do, let's take a look. 600 and about 800 was what I was getting. 600, 800. Okay, let's take a look at my chart here and see what other 6SA7s I've got that might work for us here. Okay, so here's my chart of results using the Stark. So I also tested all my, oh, these are 12s. How do you like that? Oh my gosh, I haven't done 6SA7s. Hey! Huh. Okay, well, that changes the picture here. I'm going to have to fetch all my 6SA7s and go through a big testing deal with them. Okay, not the end of the world, just I'm caught by surprise. Okay, so get back to what we're doing here. The question is this radio weak, especially on shortwave, or very noticeably on shortwave, simply because this first tube is weak? So I'm going to show you the test results from this tube and these other ones you see. This is number 1, 2, 3, and 4. Unfortunately, number 5 went in the garbage can. Let's take a look at the results here. Okay, a somewhat confusing chart, but really you should just be looking in this area here. These are all these test results are for 12 SA7s over here. So this is the 6 SA7. I don't have very many, surprisingly. The first test is the one from the radio we're looking at. It's a number 1 tube. It's in the radio right now. Just pointed to it for you. The next 3 are tubes I have, one recently acquired here. So let's look them over. There's 2 tests per tube. There's an amplifier test, an oscillator test, and the results should be 470 minimum for the oscillator and amplifier rather, and 750 minimum for the oscillator. So we can see the 550, 850 test is above the minimums. So the tube in the set is actually passing, but in terms of the maximum, I didn't write them in here. These are minimums. The maximum, not maximums, but the expected one about double these. Maybe not double this. I think it was like 900 or something. Anyway, moving on. We look at these other 2 tubes. They've come out a lot better. 950 and 1150, 900 and 1050. So these tubes test significantly better. So what we'll do is we'll pick one of these 2. Might as well pick the better one. We'll pick number 3, and we'll compare it to the radio's operation with number 1. So number 3 is the winner. Back we go. And here's the lucky winner, number 3. Now, how am I going to know that this makes a difference? Could just pop it in there, play the radio, and find out? That's just a little too subjective, I think, at this point. I think a little more objectivity would be good. So with this tube in here, we will tune in the signal generator, get a certain level, get it on this meter, and then we'll switch tubes and not change anything else, and we'll see if this had an effect. It may not be the tube that's causing this. There's a particular capacitor through which all the antenna signals pass on the way to the grid of this tube. And that capacitor could be the problem. Or, hey, it could be a combination, right? Even I could be a factor. What? Yes, I could be a factor. I was waving my arms around yesterday. That was a factor. Okay. Let's stick this ground. Now, I want this on the very handy ABC point right here. Make sure that, oh, yeah, make sure that's not going to come off. Or that'll do. This won't. Okay, down you come. So that'll give us a chance to measure the ABC voltage, or the rectified result of the detector. Okay, well, we can feed in a radio signal over, but 955 now, so that should be okay. 955 would be this band, I believe. And 955, I'm going to guess, is somewhere towards the middle of the band, I'm guessing. Switches off. Ready, 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 ready on the dim lights. Very good. I don't have my signal input ready yet. Let's get that ready. Okay, and output level of the signal generator is kind of medium. Kind of a medium level. So I didn't talk about this on the last video. Let me give it full power here. So there's a kind of hum in there. I don't know how to describe it. It's a 60 cycle sort of thing. I can hear it. That suggests to me, and I don't know, who knows? It suggests to me open grid, picking up interference, general interference, like a grid that's gone high in impedance. I don't know. Could that happen? I don't know. Okay, well, where are we on this guy? Oh, that's working good. Okay, where's the signal? There it is. Okay, we don't need the volume up. Do you hear that? There we are. This is good, actually. I just leave everything as it is. Volume's not important. Switch it off, switch tubes, switch it on, and find out what happened to that meter. Okay, that's what we'll do. Switch it off. Pull out number 1. Put in number 3. Now, I'm going to give this a, what's it doing there? I'm going to give this a 50% chance of being the fix. 50%. Got that same buzzy hum I was talking about. I should have given odds on it making it worse. Holy jeez. That's a little surprising, isn't it? Tune the radio or tune the signal generator? I'll tune the radio. Hey! What did I do? What happened there? Oh, this tube feels so... I didn't put it in all the way down. Let's just make sure I seated this tube here. Yeah, that's down all right. That seems a little better, doesn't it? I must not have plugged that tube in all the way. Now we've tuned the radio, but that's okay though. So I think that's pretty much exactly the same. Let's see if we can pick something up with an antenna. I always feel better when we're kind of using the radio the way it was intended to be used. Excuse me. There we go, outdoor antenna. And maybe we're going to pick something up here. Still hear the signal generator, I think. Wait a second. Yeah. Okay, signal generator. That's what it was. Okay, okay. Signal generator away, antenna Pick up something. Pick up something. Pick up something from far away. Oop, oop, oop. There's that scratchy spot. It's got that terrible like open circuit hum to me. I don't know what to call it. Nobody. Is there somebody there to be picked up? AM 911. Let's try 11. Nothing. And might as well try the top band. It's even quieter. It's kind of indicating that the high frequencies just having trouble. Trouble. Nobody home. Let's get another shortwave radio in here and see what there is to actually pick up. Well, bad day for shortwave. I can pick up one shortwave signal. Usually it's very strong, 11760 from Cuba. It's there every day. I can pick it up on some of my other radios at other part of my house. A little better antenna arrangement than here. Here in the shop, there isn't a single shortwave station to be picked up on any of the bands this radio will work on. So something's going on out there. I believe there's a strong solar wind right now. I think I heard 500,000 miles an hour or something like that. So perhaps something's happened. And it's just the fact is that this radio not picking up any shortwave signals doesn't mean anything, because no radios are picking up shortwave signals right now. So from what we did, changing that tube seemed to make zero difference in the operation of this radio. What about that? Okay, so the next thing then is, if it's not really the tube that's doing it, then it must be something else. Excuse me. So another possibility here, along with a low, let's call it low antenna signal getting through, maybe because of a bad capacitor or something like that, is a weak oscillator. It may be strong enough in the AM band to do what it's doing, but maybe in shortwave the local oscillator is weak. So we're going to explore that question. That's why I've got my SDR antenna at the ready here. So let's let me get the SDR onto the screen. Okay, so what I'm hoping is going to happen here is I'm going to be able to pick up the local oscillator signal with this coil, and it's going to show up on the SDR here. So first, let me get the radio going here. And we want to be on the, we're doing this in the 9 megahertz band. That should be the 9 megahertz band. Now to prove this is capable of working, I'm going to use my signal generator, which is set to, if you look, it's set to 9500 roughly. So I'm just going to take the output, just throw it in the vicinity here. Okay, it's not even hooked up. A little more juice. How about even more juice? Voila, there it is. Have any doubt? Let me just tune this a little bit. There you are. So that's what I'm hoping to see with the local oscillator in the radio. So we're in the middle of the 9 megahertz band, probably around, I don't know, I'm going to guess, 9.3. Let's make it, I'm guessing again, 9.5. I don't know that it's 9 to 10, I don't think it's like that, but who cares? We're somewhere around 9.5. So 455 above it is going to be 9.9. So somewhere around 9.9 or 10. Almost off the chart there on the SWR to the right is where we should find a local oscillator. Let me just stick this in a place where I suspect it should be easy to detect it. It's a good word. Stick this right in here. Now, I'll tune the radio, and if it's already on the screen, you'll see it move. Okay, now it's way off. I'm sure it's way off to the right there. That's the local oscillator. So it's certainly there. That frequency is about 9.9. That makes sense. I'm at the bottom of the band. I think the 31 meter band starts around 9.4. It all adds up. So the question might be now, well, is that a strong enough local oscillator signal there? I would think so. Now there's other things moving around on there. You got to kind of just ignore them. So let's try another band, because this radio worked fairly well on this band. So let's go up. So now 11. You can see the local oscillator disappeared. 11. So go up to 11. So this is the I forgot the number. Meter band. 11 megacycles. Somewhere in here is the local oscillator already. There it is. So again, it's present, and I don't think you can call that weak. Let's go up another band. Okay, so now we're up around 15 megahertz. Okay, local oscillator should appear here. There it is. So, I mean, this is a qualitative test. You can't be sure that what you're seeing there is sufficient local oscillator. But there's no reason to think it isn't, really. It's there. If I couldn't find it, well, it would be a bit of a quandary, really. But so that doesn't seem to be the problem. It looks to me like the local oscillator is okay. So now we're back to, what about a capacitor that the signals just can't get through? So let's flip over and take a look at that possibility. We'll just do it on the screen there, right there. So we're looking at the schematic. Now these high frequencies, they don't get far into the radio, because once you get to this tube, whatever's on the antenna is being converted to 455 kilohertz for the rest of the radio. So if there's a high frequency killer in here, it's got to be in this area. Now if we look at the grid on the first tube, the grid that is connected to the incoming signal, that's this guy here. You can see the incoming signal, no matter AM or shortwave, is forced through this capacitor. So that's one guy, and he has a fair size, 330. He's got capacitance to lose. Maybe this guy's bad. Now, it's a highly reliable style of capacitor, so, fat chance, but maybe. Indications are he could be bad. Now, what else could be bad? So I think this guy is carrying the local oscillator, which we appear to have found. And there's another picture in here, and that is there's a trimmer that, let's check this out. There's a trimmer that I ended up just opening all the way. Seemed to help. But that's not normal. Trimmers should not open all the way. So here's a trimmer here. Which trimmer was it? It was trimmer
I believe it was this one, C4 31. Yes, C4. So find C4 on here. There's C4 right here. Now, what is C4? You know, it's hooked up to this crazy switch. What is it actually doing? It's supposed to be adjusting the oscillator, isn't it? Let's look at the table here. C4 star star. No, it's an antenna adjustment. Right. So I wide opened this antenna adjustment. Star star. Capacity antenna lead should be removed from the antenna and ground terminal board and ground terminal board and ground terminal board. Oh, I didn't do any of that. Now the capacity antenna is missing in this radio. And ground terminal board. What are they talking about? Ground terminal board. Ground terminal board. What are they talking about? So this might be part of the problem here. Maybe I didn't do this quite right. From the antenna and ground. And ground terminal board before adjusting C4. I don't know what this really means. Terminal board. How do you ground a terminal board? So maybe I'm reading this wrong. Maybe this is should remove it from the antenna and remove it from the ground terminal board. That doesn't make sense either. There's just one wire coming back from this capacity antenna. Capacity antenna should be removed from ANT and ground terminal board before adjusting C4. Well, what's the terminal board? What's the frequency, Kevin? What is a terminal board? Is it stated in here? Terminal board? So these are the antenna and ground terminals. So there's the capacity antenna. It says it should be removed from ANT, but it's just an A here. That didn't help. What silly nonsense. Another node rearrange switch. No, that's not going to help. Well, and ground. Oh, okay, let's see if we can read that differently again. Capacity antenna lead should be removed from the antenna, and the ground terminal board should be removed from the English didn't work. Capacity antenna lead should be removed from ANT and ground terminal board. Huh. Okay, so maybe there's something called the antenna and ground terminal board, and you need to remove the antenna lead from the antenna and ground terminal board. You know, that makes sense actually. The antenna and ground terminal board, because you could call this the antenna and ground terminal board. The problem is, it's not a problem. Not a problem. It's just the way they've written this. It's blowing me away. Okay, I think I dwelled on that enough. I almost killed myself on this. So I think what the bottom line is, you don't want the capacity antenna connected while you're adjusting C4. Capacity antenna is not connected on this radio. Never been, so that didn't affect the adjustment of C4. So again, I go back to the real problem. Why does C4 want to be wide open? And wider than wide open if it could be, because That's a strange thing, isn't it? Why does the trimmer require extra less capacity? Because something else has got extra more capacity that it's trimming against. What could have more capacity? What increases in capacity? Nothing, as far as I know. Everything is just going to lose. It's not going to increase. I don't know what to make of that. Clearly something's up with this. I could repeat this. I could adjust this again. Hey, that might be a good idea. Why don't we do that? We'll try this again. C4. And it's not really clear here in the schematic what it's adjusting for. But it must be related to the antenna, not the local oscillator. Because the only thing you can really adjust with the local oscillator really is the oscillating frequency. And this is adjusting the overall strength of the output of the radio. So it's got to be adjusting the input antenna. So maybe, bad capacitor here, trimmer acting up, change this capacitor, trimmer all happy again. Maybe that's the scenario we're heading for here. So let's take a look. Let's find this. Find this guy. He's off of, oh my god, pin number 1 on the switch. Yikes. Occasionally they position these switch wafers on a diagram like this so you can recognize them there or arrange the same way they are in the radio, but I bet you that's not the case with this one. Pin number 1. Well, let's see, there's a capacitor going to ground, and then there's another capacitor coming right out and heading for the grid over here, so it might be easy to spot this. Plus it says 330, maybe I can even read it. Let's go, check it out. Okay, so I'm just trying once again to identify the particular capacitor I'm interested in. I pretty much convinced myself it was this one. All indications are it's this one until I actually read the value on it. The value is 56. It's supposed to be 330. 56 is conveying the local oscillator to the first grid in the 6SA7. The signal from the antenna is getting to the second control grid some other way. So there only is, well, oh boy, there's one hidden way back in here. You can barely see it. Right, kind of tucked right inside the switch here. And the other one's not much better. Oh my gosh, there's 2 more down in there. So another one of these black ones, and then a more typical mica, square boxy mica one down under there. I think that's what that is. Oh boy. Let's just get the close-up camera on this because okay, first of all, the imposter, the guy I thought was the 330. I don't know if you can read it, but if you look long enough, you'll see it says 56 upside down there. Other ones, well, there's a resistor buried in there too. Yeah, that's right, Peanut. Okay, maybe we can read the value of this one. Let me just fix the focus on the camera here. We'll get in close. Get way in close here. Oh, maybe. Yeah. Right, Peanut. Okay, gotta fix the focus here. Okay, let's take a close look at the capacitor here. So first of all, the 56. I'm going to flip my camera upside down. $56. Good. Now, what about that one back there? My poor cat Peanut, he just wants to go outside, but it's nothing but a rain out there. What's that say?
sure what that is. I come at it from here. Yeah, looking at the condition of it here too. Oh, hard to see among all that stuff. Yeah, peanut. Okay, what's that say? I don't think that's the value. I think the value must be on the other side. Shoot. Well, there's another one. It's even harder to see. Right over here. Tucked right inside there. Oh boy, oh boy, oh boy. So, yeah, does that seam look like it's cracked right open there? Kind of looks that way to me. Could just be the shadow here. Let's just move this. Yeah, it's just the shadow, see? Besides, I had one of these out of the radio and checked it, and even with a crack in the shell, it still tested quite good. Is this the guy? I think what I'm going to have to do, I'm going to have to replace all these anyway, just in the process of eliminating the possibility that these are a cause. So it's probably not as hard as it looks, he says, telling himself. What other objective test could we do here? Right! That's right, Peanut. He's cheering for the objective test. Oh, well, one is we can just try to read the capacitance. Let's just try it. Even though they're in the circuit. Let's try this one. Hard to grip on here. Not really. I don't know. Okay, hold it on there. Even in the right spot. Yes. Okay, here we go. Well, it's showing it as a resistor, 0.12 ohms. Wow, how do you end up with that? A short circuit. This is showing it as a short. Is there a short there? I don't need this thing to find that out. Is it shorted out? That's interesting. I kind of doubt it. It could very well be just because the switch is in a certain position here. This capacitor is shorted out. Ooh, right to zero. Hard to see on my. Yeah, it's all zoom right to zero. Hey, let's put that back on there. And watch this now. Up here, up here, up here. Okay, so I've just flipped it. This is the, this would be the 19 meter band. One band back. Wow. No, I'm wrong. This is a short wave. And that's AM. So, when you flip it to short wave, this capacitor gets a short applied across it. Probably exactly what's supposed to happen. So let's take the short off, and then we'll test it with the other meter, see if we can't get a capacitance on it. So probably all is normal here. There, that's a little better. Okay, 105 picofarads. 330. Well, one of these is 330 picofarads. Where's there a 100 picofarad capacitor? And if this capacitor were 300 picofarads, I would think you're going to read under this kind of test with it in the circuit 300 or more, not less. And less would be a symptom of a capacitor that doesn't have its capacity. Where would its capacity go? There's another one back here. I'm going to try this one. This one's showing 1,000 picofarad. Sounds kind of crazy. That's a lot more than 300. But it's in the circuit. And just for fun, this one, it's hanging right here. And I know it's supposed to be 56. What'll happen? Look at the reading, way, way high. Okay, so this one I took out earlier, 220. 220, eh? So it's supposed to be 220 and it tested 230. Just another kick in the pants for taking these out when they were good. Good. Let's test the other one. Let's not stop here. See, my experience with these has been pretty darn good. $179. It's supposed to be 150, 180. I think it's 180, 179. Look at that. So which of these is the one I'm after? Oh my gosh, must be this one. How can I prove it? It appears that this terminal of the capacitor goes into this coil, and the other side of the same capacitor appears to be going into the coils. It's a capacitor closely related to the coils. Isn't it? Let's take a look. Capacitor closely related to the coils. What coils? Those are the three. They are these three coils here. Again, how this is laid out on the schematic is not terribly helpful. There's a 620. That's probably what that is. And there's a 62. So what happened to this guy? I haven't found this guy. It's not a black. Maybe it's not a black one. Maybe it's not a black one. Maybe it's that other one that's buried way in there. Uh-oh. Okay, 330. Let's go back and look. I don't think I've found them yet. So there is another capacitor, kind of a mica one. Oh, let's go back to the schematic. I think I can figure this out from there. Because if we're looking for C3, and then on the parts list, it's going to tell us what kind of capacitor it is. Oop. There. Here's C3, 330. It's not saying anything.
just looking at the others here to see. That's interesting. Look at that one. Close tolerance. So they're warning you that this one's critical. Which one's that? C15. Well, this didn't work. This didn't help. Doesn't identify the type of capacitor. Okay. Hey, look at that. Board, antenna, and ground terminal board. There it is. Board. Dash. Antenna and ground terminal board. So that's the official name of that part. So that means when I was reading that other part of the schematic, I finally did read it correctly. Okay. It challenged at every turn.
Probably the best thing I can do is stop for lunch at this point.
So a contact made here, rotate the switch once, different capacitors going in and out. Oh boy, that'll just break my brain, especially this late in the morning. Really, I think I reached the end of the road here. I have to have mercy on myself. Yeah, I think I'm just gonna stop and think hard about all this. I don't want to get in here and replace all these capacitors for no benefit and lots of risk. Poking around in there, oh boy. Some of these capacitors are in there. The leads are incredibly short. There's reasons for that. If I'm going to get in there and replace them, I'm going to do a sloppier job. I can't do a factory quality job here. So, wow. Don't jump in there and do stuff. Let's continue to work on the idea that there's something else amiss aside from these capacitors. So I'm focused on these capacitors. I have no real reason other than just an idea I've conjured up. So more testing needed. Oh, okay. That'd be it. Time for lunch. See you on the next video. Okay, sorry this is kind of just ending out in the middle of nowhere, but that's kind of where it is. So I'll catch you on the next video.
Okay, so lunch is over. Now I got an idea here. Maybe I can feed the signal into the radio, maybe right to the grid. In fact, that's what I'm thinking of doing, right to the grid of the first tube, and hear what the output is like, and then move the signal to the antenna, and it should be pretty similar, really. We'll see if it drops way off, and then that would suggest something's going on between the antenna and the front of the radio. I think I gotta have this on the proper band, which should be the 9 megahertz band. Let's switch it on. Okay. The signal generator is tuned up to 9535. We'll just find that on the radio. Let me put it on the antenna to start. surprising to me that just changing my signal generator by a factor of 10 makes the radio go from nothing to a fairly good response. Okay. Going into the antenna, actually through a little resistor there. Let's just go on the other side of the resistor. So we're at 7.5. Got a lot of hand influence here. Okay. Hands away, 7.2, 6.7. Okay, slightly bigger without the resistor. That makes sense. Now we'll stick this right on the grid. The grid, I have this clip lead on it already here. So we got a resistor in here and a couple other things. I would expect, let's see what we get. Much higher response. So fed directly to the grid, we get a really quite strong response there. Fed through the antenna, this is even with this capacitor and resistor deal here. Fed through the antenna, we get a weaker signal. It's not too surprising. I guess this tuning doesn't do anything anymore. Oh, it still does. Oh my gosh. What's happening here? Okay, this meter's a little too sensitive to begin with. So that's half a volt ABC. We'll just turn this down a bit. About half a volt ABC. Hugely weaker. Is that because of tuning? I wasn't expecting that. So it looks like you send the signal in the antenna, the radio tunes to one spot, feed it straight on the grid, and the tuning still affects it differently. It must be affecting capacitances that are involved in the resonance of the tuning. Doesn't really make sense. Does that make sense? Because what's moving is the local oscillator, isn't it? Huh. Well, this has only raised more questions. It hasn't really solved anything. But it looks like you can get a nice signal to the grid. You're golden. Now I could just go back one step, but it's really tough. I'd like to just go back and get on the other side of that question. It's the same 330 questionable capacitor. Let's see if I can do it. So right now, let me tune the radio. Okay, right now we're getting 4.5 on there. Okay, you can still see the meter there, 4.5, eh? Here we go. I think I got it. I didn't hear a thing. There it is. Oop. 4.5. So I put the signal in either side. Let me bypass all this stuff. I'll go right in here. Ooh. Four and a half like that. Pretty sure I saw 4.5 on the other side of this capacitor. Yeah. Okay, so that kind of eliminates that 330 capacitor, I think. Don't do that, don't do that. Meanwhile, nothing from the antenna. Okay, so I think we're working our way towards it. How's that link? The link is closed. You know what? That closed link is causing the problem here. I think this is it. I think this is what's doing it. I should not have this closed. Well, it didn't make a big difference, did it? Our next, I still have this capacitor way open here. Let me close it up. Something has happened in the meantime, I don't know. Scare ya? Scare me. Come on. What's with the screw here? Okay. Closing. Quiet, 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 quiet. Open. Circuit diagram. So I found putting the signal in on this side or this side makes no difference. It appears putting the signal in from the antenna, a link closed or open, makes no difference. I believe what you're doing is you're driving the signal through this transformer, and out of it is coming the signal the radio's picking up. This doesn't seem to be doing its job. So open L2, I doubt it. You got to prove out this coil. L3, 4. These are all. This is you know what? I really don't have this. Do I? What am I saying? Can you complete a sentence? No, not really. Just checking the band switch. Maybe I can pump a signal right into here somehow. Let's try that. So that's going to be this guy, I think. Is that retuning the radio? No. It's weakening the radio. Good. I don't know if that's good or not, but so that's the guy there. There's the 3 contacts down there, and then 3 from the top. I can't see where they're going. Okay, there is a place I can feed a signal in though. Goodness knows if this makes any sense doing this. So much signal just flying around on this. It's extremely unlikely that coil is in trouble. The wire's pretty heavy on it. So what about that trimmer? Yellow wire. Just to the back there. Could it be the switch is not working? The band switch has still got an open in it somewhere? Not making enough contact? Again, that's not very likely. Wow. Schematic. So what I did was I touched one of these terminals here, and out it came. Primary. I wonder if I can spot the primary on that. And see what's up. Because the grid in shortwave is connected to one of these three wires and everything else is ignored in the radio. So this would be the only way in on shortwave. The signal has to be on here. The only way for it to get on here is to transformer itself from here. What's up with this primary? What's up with this? Okay. Can we check this primary? So we're into things that I seldom concern myself with or have to concern myself with. So I'm 90% sure I'm way off track, but I'm kind of in elimination mode now. Just trying to eliminate things that might need elimination. So looking at this coil and trying to figure out where is there a primary. So there is a small winding at the bottom. So that's probably the primary down there. A separate winding. Wow, it's really hard to tell. So that winding, there's an internal connection in there. Doesn't look like it. So that's a winding to ground. One side is the antenna, and the other side, the other side is the ground. Huh, I don't know. Okay, so this primary side here, I should be able to read the resistance of it by simply reading between this screw and this screw, because they're just connected across it. So let's try that. A and the screw in the middle. There it is. Oh, wait a minute. Really? Oh, so it could be open circuited because the band switch is set somehow. Let's move the band switch. Not supposed to be like that, is it? It should be through this coil. It should be like 5 ohms or something. Maybe I just found something here. So the two screws I was hooking up to, they both attach to wires that come through the top here and head right right into this whole area. Wow, it's one come all the way down to there. Let me just grab it. No. The radio's not on, eh? Oh yeah, well, it comes all the way to here. So there's a wire. Which one is it? It's this center one. All the way up, all the way along, all the way down, and loops back to here. Reaching the coil I'm curious about. The other wire looks like it goes through a switch. Okay, is that the case? Is that really the way this works? I don't know if I got enough lead on here to try this. Let's try it. I go from here. No, I don't have enough lead here. Okay, so we're talking about down here. One end of a wire and the other end's way up here. Hey. The other one? Wait a minute. How'd that work just now? Yeah, I grabbed the wrong one, did I? No. So this wire should be the same as this. Should be the same as this. There we go. Now we're cooking. 0. Okay, so that is definitely that wire. Now this other one, I don't think it goes all the way back here, does it? In fact, it does. So the two screw wires back here actually to this coil. So this is the primary of the coil. So that means we should read a resistance here. A low resistance here. So there we go. Open primary. Really? Really? Oh, maybe not. Oh boy. Maybe there's a did they make diagrams of these? I don't remember. I don't see any. What about elsewhere in the manual? They just threw them in somewhere, didn't they? Looking very carefully here, just in case they've hit it. No. About here? No. So unfortunately, they don't have a diagram of the coils. No. Phooey. Okay, so I gotta spend some more time figuring out the terminations on that coil. Okay, let's take as close a look at that coil as we possibly can here. Set is off. So first of all, the wire termination. This is one of the two wires coming from the screws on the back. I mean, it's clearly soldered on. The other end of this terminal is going to have the lead wire soldered to it. Kind of see it wrapped under the solder there. You should be able to see it come up to it somehow. Just a sec here. Get a little more lighting on the deal. Oh, so I would think a wire would drop. See the fine coil there, the fine wire. That's interesting too. That I would think would go down to that terminal. I don't see any wire going down to it. In fact, I see what looks like a little piece there hanging there, and I can't see anything else because of the lack of lighting. Wait, I just rotate over here. Just rotate, man. Rotate, knock down anything. What do we see now? You really gotta wonder, how would that ever get broken? In there, I just don't see the wire. Occasionally these things are inside the tube here. That's possible. Come on. So I see a little tidbit of wire on the right hand side hanging there of the terminal, and it just looks like it's broken away. What about the other terminal? Let's see how the other terminal's done. The other side. Here's the other side. Get some light on it here. So there. Oh. So, come on. Sorry for the camera. So there. Oh, now we can see things more clearly. Both wires come out of the coil at this point. One of them wraps around. Sorry about the camera work, but I'm holding the camera sideways. One wraps around, goes to that terminal. That's easy to see. The other one heads this way. Heads this way. Heads this way. I can see it there with my eyes here. You know, I'm going to poke at it. Hang on one sec. Just grab myself a poker. Hold on tight. Riding the roller coaster there. Okay, let's see if I can get this kind of on it there. Nope. How about this way? Up like this. Yeah, perfect. So where's that wire going there? Oh, this is not. Wait a minute. I need a much better pointer. Here, I got one. Poker, stabber, needle. I don't want to stab anything here. Okay, so the object is to lift this wire and see what happens. If I can get under it. Is it loose at all? That wire's not loose at all. But it really looks like they took it off, like pulled it out down here. There. Pulled it out, brought it over the stopper tape, a little piece of stopper tape there, and brought it back across the top. I can really see it with my eyes here. Let's see if I can get my camera on it. Brought it back. Come on. Here. Brought it back to here. Oh, look. There's the end of it. What happened in here? Sometimes when I see stuff like this, I think to myself, this was broken the day they made this radio. It's really not possible because the radio will go through pretty careful testing at the end of the production line, and a mistake like this, they would find it. So how else can something like this get broken? I mean, it's way down in the radio. Corrode away. It was damaged during installation with a nick in the copper, and then tiny flexations, and eventually it breaks at the nick. But look, there's a whole bunch of copper missing here. Oh. Okay. Bolt of lightning. Something bad happened with the antenna lead, and either got a shot of electricity from something like a bolt of lightning, It wouldn't take much of a, it would take the tiniest bit of a bolt of lightning to burn that wire off. Or the antenna contacted, the chassis was hot, the antenna contacted something, regular house power tried to flow through it. Something, I think, blew this wire off. I think that's what I would say. We're looking at the scene of an explosion. Pow! Well, all I got to do is just put those back together and this radio will behave a lot differently. How the heck do I do that? I have to extend that wire. You know what I would do? I would solder first something onto the terminal and bring it out close to where the other wire is. And then wrap the other wire around as much as I could, apply a whole bunch of solder, and click my heels 3 times. See if that works. That is the problem. Oh my gosh. Wow. Okay, well, that's a good day. It's almost 2 o'clock in the afternoon here. But I have found it. Wow. Okay. I gotta stop now because I gotta go grocery shopping. Oh my gosh. So I think I'm gonna try to fix this tomorrow, having found what the problem is. I think that's good enough for today. Maybe tomorrow I'll find out this isn't really the problem. Okay, thanks a lot for watching and see you.